let's see third approach to solve this coin change problem. So I already talked about two approaches in last two videos. So one is not very efficient way, but that gives the solution. And another, in the last video, I talked about this solution, coin change helper 2, that is DP and using the recursion. And that's a good solution. Approach 3 I'm going to talk, and I like this solution best. So let's try to solve this problem using the approach 3, that is DP array. So let's understand the problem once again, and then we'll use the DP array to solve this problem. And for this solution you can ignore this function because I already explained this in a last video, but I will write in approach 3 here, and this is the function coin change, and I'm going to write code here. So the problem is, let's understand once again. These are the coins 1 to 5, and we need to use this coin. We can use any coin that's multiple of times to make it 11. So if I use 1 11 times, I get amount 11. If I use 5 2 times, 10, and one coin one time, then that becomes 11. That in this case I just need 3 coins, 2 coin of 5 and 1 coin. So I want to find out the minimum number of coins that make this amount. If I use the DP array, what I do, like other problems similar to DP array, where we create a DP array. So I'm going to create the DP array, and the DP array size will be whatever the amount plus 1. That will be the size. That's the usual way we create. Like we always create one more space in a DP array. So here I'm going to create that array first, and then after that what I do, I will iterate through this 11. So I'll iterate through the 11, and then when I iterate through this 11 from 1 to 11, and I consider, okay, 1 to 11, like 1 is a amount, and when I iterate, then next time I'll get 2. So 2 is a amount, and like 3 4, and then at last 11 is a amount. So here, like, there's only one amount. We need a coin to find out this amount, how many coins we need to find out this amount. But in a DP array, what I do, I will try to find out for the 1 how many coin is needed, for 2 how many coin is needed. Like let's say amount is 1, then just 1 coin is needed. If the amount is 2, there's 1 coin is needed. Amount 3, then in that case I need the 2 coin, 1 and 2. So first of all, outer array will have this all the coins, not all the coins, but outer arrow has all the amount starting with 1 amount, 2 amount, 3, and then what I do for the amount 1, how many coins I need. For this, again I iterate another loop, inner loop, and I will check with all the coins. Like let's say for the 1, if the amount is 1, then which coin I need. So in order to find out all the possibility, I need another loop and go inside and find, okay, 1 I need this coin to make it 1, 2 no, ignore that, 5 no, ignore that. And in that way I store that result in a DP array, and then in order to find out another amount, I will use the result calculated previously. So that's what I'm going to do. Let's see the code, and then we'll come back and try to understand what I'm saying here. But this code is very few lines of the code. So first of all, I'll create the DP array. So make, and that's int, and the amount 11. So that's the amount plus 1. That is the DP array size. And in a DP 0, I'll just put 0. But because there is no 0, like if you say like 0 amount, then just we need the 0 coin. So that's why just DP 0. And then I'm going to have one iteration through the amount. So I will start with I is equal to 1 and then I less than equal to amount. So if amount is 11, less than 11, and I plus plus. So in this way, we get 1, 2, 3, 4, and all are the amount. And for the one amount, how many coins I need, that's I have to find out. So for that I need to check all the possibility of this amount. So I will iterate through this, not amount, but this is a coin. So I'll iterate through this and see is a coin here, range, and I can say coins. So here I will get the coin. Let me write the coin also. So we'll get is by one all the coins. Now we'll check the condition, like if coin is less than equal to I, because that is the I is I is the amount. First time it's a 1. So for that I need to check like which coin is required. So that's why I have to check if it is equal means I can use that, and if it is less than that I also can use and try the possibility. So that's why this condition is required. And then I can put here dpi is equal to, I will check the minimum of this the coin itself, or not a coin, but I can say minimum of that dpi, whatever the value already is in the dpi. Okay, so I just remember, so in a first, like we need to check compare with the dpi. Then first of all, in a dpi, all dp array, we need to put some higher value over there, so that we need to find out which one is the minimum. So for that I'm just going to initialize the dp array. So I can say I is equal to 1, I less than amount, I plus plus, I less than equal to amount plus plus, and then I can say dpi is equal to, I just say amount plus 1, so some higher value of our final amount. So I initializes that, and then here I can check our main the logic here. We need an analysis for this logic, but I can check the minimum of dpi, and then I'll check that's I, that is the main amount. First of all is a 1, so 1 minus coin, whatever either will get, so coin, and the I in the sense, so I minus coin, and we can check that in a dp, so whatever the value in a dp, and then plus 1, and that's the minimum. we can put that in a dpi. So what's happening here, we'll understand this thing, but let's try to run this, and at the end we can return dpi. So that's the solution. Let me run first and check, and then we'll see that. Line 43, there is some addition. So the minimum of this 1 comma okay, that should be this bracket. Okay, so dp return, no, dp amount, we have to say like dp amount. The wrong answer is correct for test case. So for this answer is, let me make it a little bit bigger, case 2, 2, 3. Okay, it's checking here itself. Let me run once again. Wrong is for 2. Okay, for the 2. Okay, so that's the one more condition, like because I put some higher value here, so I can check one more condition, like if this dpi is, or dp, not a dpi but dp amount is greater than amount, then in this case return -1. That's the one, the corner case we need to handle. Let me check. Accepted, submit. Okay, so this is the accepted. Let's try to understand like what's happening here. So in order to understand that, let me print this value first. But anyway, this code is this much is code, very handy, this Approach-3. It's very small code, but let's try to understand. So for that I'm just going to print this dp array, and then we'll understand this logic here. run it. Okay, and here for the case 1, we'll see I have printed this value, so dp array value, and that this is our answer. This is a 3 because I need like 5, 5, 10 and 1, so that's 3 I'm returning. That's 3 here. I'm saying return dp amount, and amount is 11, and that's a 11th position, because this is array is 11 plus 1 12, and this is the 11th person. That's the answer. So how it's happening, how it's getting calculated, let's go through this, and you can go and dry run by yourself and just try to understand this, how the flow is happening. But let's go together with me now. So let's say first time I is equal to 1 here, and our destination is, okay, I want to make like this one I1. So here, so my target amount is 1. I want to make 1. So for that I want to go and iterate the coins. So in the coins, 1 to 5, so we'll check the coin less than equal to I. So coin should be less than I, so I is 1, so should be less than 1. So only this is only allowed, this 1 is only allowed here. So we'll get the 1, and then our logic is here dpi. So in a dpi in this position in a beginning, that's value is the 12, we know, because in the beginning all we initialize with 12. So in this case it was 12, so we are checking dpi, we're checking which is the minimum dpi. So dpi is a 12, so here it was a 12, so 12 comma, and we want to know other value, so I minus coin. So I is our 1, and coin is also 1, so 1 minus 1 0. So in a 0 index will go, it's a 0, and we are adding plus 1, and we put that result here 1. So we are utilizing this 0 and put the result 1. So in a 1 and previously it was 12, so between 12 and 1 is minimum, and I put the 1. So that means I just need 1 coin to make 1. If the amount is 1, instead of 11, if the amount is 1, then I just need 1 coin, and that's I put here. Now I'm going to use this result to calculate this value. So in this value, let's say this is 0 1 2, so index is 2. So index is 2, that means just consider this is a new amount, that is 2. So to make 2, how many coin I needed to make 2? So to make 2, I can have like 1 1 2 coins, or I can have 2 1 coin, just 1 coin 2. So result is 1. So here is the result is 1, but how we got the result, let's calculate this. So previously it has the 12, and now the I value is 2. So 2, and then we get the coin in an inner loop. This I is 2. Now we go to the inner loop and we get the coin 1. So this time I is 1 and this coin is allowed. So I say that 1 minus 1. So from here I'll check 1 minus in order to calculate this in a dp array 1 not a 1 minus, but this is I is a 2. So we'll say that 2 I is 2, and the 2 minus 1 is 1. So we'll come to this place 1 index, and in 1 index we have already calculated the result 1. So 1 plus 1 2. So that 2, and it has already a 12 here. So which is the minimum, 2 or 12? Then we'll put that 2. So 1 1 2. So we put the result 2. So that means we need 2 coins of 1 1 to make 2. So that is a one solution. But wait a minute, but that is not the final solution, because next time we'll get another coin. The 2 is also allowed. So 2 is also allowed here, and then this time still I is at 2, and the coin is also at 2. So this time we'll do the 2 minus 2. So 2 minus 2 is 0. So we'll go to this place, and in a 0 we have the 0 value, and then 0, and we'll do the plus 1. So we'll get the new value 1, and there was already a 2 here. So 1 and 2, which is the minimum? 1. So we put the 1. So in this case, we know that in order to make this amount 2, because index is 2, in order to make amount 2, I need just 1 coin 2 here. In the similar way, you can try all those things, but I'm just going to talk a few more here. Like this is a 4. So in order to make 4, how many coins I needed? So you can see for the 4 I need 2 2. 2 and 2, 2 coins. So that's also based on this logic. In the same way, we'll come to this place, and this is the 11th index. So for the 11th index, how many coin we need? So we say the 3 coins we need. So by yourself, you can go and understand this thing, this flow, and then it will get the clear idea. So but anyway, this is the best approach, I say. So that's all for now. Thank you.